Hi, we're going to go through metric conversions. First of all, we got to do our units. So we've got T. I just call this Tugumuk, and then King Henry died by drinking chocolate milk, and then I say Mumanoop, and it gets a little bit longer on this. Do we actually have units that are larger and smaller? Yes, we do. We're just not using them. So this would be tera, giga, mega, kilo, hecto, deca. These are my base units. That's why we have B. Base units would be liters, meters, grams, and seconds, and a unit called moles. And we may have others, but that's what we're going to use for right now. Now as we start moving down, we've got deci, centi, milli. This is called micro, nano, and pico. Generally, if you're using units up in here, most common thing that uses those is called computer. So we got something called terabytes, gigabytes, megabytes. We used to deal with kilobytes back in the old days when we had to use a stone with our computer. I'm just kidding. And then on the other side, we got our smaller ones. We're using nanotechnology right now, which means very, very small. Pico is even smaller. Pico is actually used for measuring atoms and things like that, because it's a useful unit. I'm going to go ahead and erase this. Let's go ahead and start using metric conversion with this. First of all, I'm going to do an introduction as far as, showing how to do a conversion. And we'll go with easy units. So let's say I have $17 and I want to know how many dimes that is. Well, we're still using significant figures, so we have to kind of think, well, at the end, I got to go 2 sig figs. Okay? And then I can start moving my way down. Actually, it's a pretty simple way of moving down to this one. We got dollars, dollars top, dollars bottom. I want to move directly into dimes because I can do that rather easily. Which one's the big one? Because we always look at the big one. This is the big one. How many dimes are in a dollar? 10. How many dimes do I have after I cancel those out? Because that's what I have to do as I am moving. I am canceling. Top, bottom, cancels. I'm in dimes. That's what I want. Calculate. I have 170 dimes. And look at how nice it came out, because this is 2 sig figs and this is 2 sig figs, because trailing zeros do not count. This is how it works with money. Let's go ahead and do a time one. Again, we're not here yet, because I'm going to start adding them all together. So let's say I want to go, let's see, I wanted to do time, so let's go 185 decades equal seconds. Well, instead of sitting there, saying, well, I gotta multiply, divide, I don't know. All you have to do is do conversion. It makes it nice and simple. And we use conversion all throughout chemistry. So I got 185 decades. How am I going to cancel out decades? Well, I got to put decades at the bottom. So I'm going to go decades. I'm going from a larger to a smaller, so I got to start progressively going smaller. So now I'm going to go to years. And it doesn't matter what the conversion factor is, just as long as it's correct. I don't know many that go from decades to hours. That would be a problem. Or days. So I have 1 decade, which is the big one. We always look at the big one. And I have 10 years and 1 decade. Those canceled out. Am I done? No, because I got to go really small. So next one I'm going to go is years. What's my next smallest unit? Days. Which one's the big one? Years. I have 365.25 days in 1 year, because I want to be very specific. Boom, boom, now I'm in day. Now you notice I'm getting even closer. So I got day at the top, got to cancel it with day at the bottom. And what's my next smallest unit? Well, I got hours. Which one's the big one? Day. And then I got 24 hours in 1 day. Those cancel out. Let's keep going. I got hour at the top, hour at the bottom, because I got to cancel it out. And then my next smallest unit is going to be minutes. Which one's the big one? Well, I got 1 hour. How many minutes? 60. 60 minutes equals 1 hour. Now I'm in minutes. I'm getting even closer. I can see the end. Amazing. I got minutes at the top, minutes at the bottom. What's my next smallest unit? Seconds. Which one's the big one? Minute. I got 60 seconds in 1 minute. And now I'm in the correct unit. And again, I incrementally go smaller, going with my known numbers in units. Then all I have to do is just multiply. And here's what I end up with. Now remember, if you're using the kind of calculator we are, it's just going to say E10, which means the same thing as times 10 to the 10th. That would be seconds. We still have to deal with significant figures. We have 3 because they all count.
Point this interruption. At this time, we need all paraprofessionals to report to the library. Please, all paraprofessionals, report to the library at this time.
Now be careful with the significant figure rounding. We're going from the 8 up to the 3, which would make it 4. So we're going to go 5.84. Do not put a 0 at the end, because we only want 3 sig figs. If I put a 0 there, that would make it 4. Times 10 to the 10th seconds. And that is your answer. Again, the answer would be rather large, but we're not going to worry too much about it, because that's the way it's going to be. Now let's go ahead and start throwing in these metric units. You'll find metrics are a whole lot simpler than using the English units, because we don't use weird numbers. Metrics are based on 1s and 0s. So let's say I want to go 25 kilograms, and I want to figure out how many grams that is. Well, a metric conversion is rather simple, and we can use this little diagram for it. We know that the grams are here, because it's a base unit. And we know a kilo is here. So I just set it up. We know we can go directly from here to here, so I just follow pattern. kg, top, kg, bottom, cancels, grams, top. Which one's the big one? Kilo, because the one on the left is bigger than the one on the right. And then all I have to do, since it's based on 1s and 0s, is put 0s down to wherever I'm going to. which in this case is grams. And we go 1,000 grams, big one, kilograms. We go cancel, cancel, then I multiply. And we got 25,000 grams. So if you notice, metrics are pretty easy. We could also do it in reverse and use the same conversion factor, but I will just go ahead and do another one. And we'll use these smaller and bigger units now. Let's say I have 28.8 nanoliters equals blank megaliters. Now you'll notice we're going from here to here, but again, we're more interested with the big one because we know that's always going to be a 1. And we're going to go all the way down to nano, which is here. Now you'll notice I'm not writing down zeros. There is another way to approach this. So we go 28.8 nanoliters. Let's follow pattern first. I've got nanoliters here, nanoliters bottom. Since I'm dealing with the same sort of thing, I can go megaliters here. So now, which one is the big one? Well, mega's the big one, so we'll put a 1 here. My other number is going to go with nano. You can remember that we can use exponents for this type of number, especially when it gets a lot of zeros. And they go in sets of 3. So this one would be 3, 6, 9, 12, 15. So that would be 10 to the 15th nanoliters. Then all I have to do is just divide these. So I got 2.88 times 10, and you throw that on a calculator, you're going to end up with times 10 to the negative 14 megaliters. And that would be your answer. So in that case, you get larger, you can do exponents. By the way, if you don't want to do from here to here with 1,000, you could also go 1 times 10 to the third. So it doesn't really make a difference because those values are all the same. 1,000 and times 10 to the negative third. Let's go ahead and do some multi-unit conversions. So let's say I'm putting in 25 milliliters per second in a lab, and I'm trying to add up to liters per hour. This is the reason we use conversion, because sometimes these things are not going to be just looking at it and knowing if you're multiplying and dividing. That's why you always have to show work. You have to know, or I have to know, that you know the process. So we're going to go this. This part here just means per 1 second. If I'm driving 80 miles per hour, it's per 1 hour. I'm going to follow my pattern. I think I'll just go ahead and go from here to here first. So I'm going to kind of split it up in 2. So I got milliliters here. I want to cancel it out, so I'm going to put milliliters at the bottom. And now I know I can go from here to here directly. Because again, I'm dealing with liters, which is a base, and milliliters, which is here. So which one's the big one? Well, this one's a big one. And this one, 1000, is the smaller one. Milli, milli, cancel out, liters, liters, they match up. Now let's go ahead and go from seconds to hours. Well, I got seconds at the bottom, what's going to go at the top? Seconds. What's my next unit up? Minutes. Which one's the big one between seconds and minutes? Well, we know minutes is the big unit. So we got that. How many seconds are in a minute? 60. Now you'll understand or look, every time I see the big one, I always put a 1 there. That's good practice because if you're just going through here, you don't want 1 second equaling 60 minutes. You want to look at the big one and just put a 1 there because the other number will go where? Well, in this case, it goes at the top. It's the only place it can go. Seconds cancel, because now I'm going bottom, top. Now I'm canceling it out. I'm just going the opposite way. Now I got minute at the bottom. Next step, minute at the top. Next one, hour. Which one's the big one? Well, my hours are the big one. And then 60 minutes at the top. Again, understanding that every time I see a big one, I put a 1 there. Now am I done? Well, I started getting rid of it because I know I'm in hours now. And now I am completed with it. The next step would be to calculate, because now we're dealing with more numbers as far as calculation. Now if you're proficient at math, you're going to notice I got these here. Those cancel. So now I've got 90 liters per hour. Now what about my sig figs? Well, I got 2 here. How am I going to make this 2 sig figs? Well, again, I got 2 ways around it. If I put a decimal, I know that makes them count. Or I could also put 9.0 times 10 to the first power. And that would also be correct. Of course, make sure to put your units, liters per hour. Now what we're going to be moving up to after this next one is actually moles. But first of all, we're going to use some different units, and I'm going to kind of give you some hints as far as dealing with that. Let's say I'm driving 2,500 miles per hour. And I want to know how many millimeters per second that is. Now let's go even funnier. Let's go nanometers per second. Well, again, you don't want to, I don't know what the conversion factor for miles is, and I'm dealing with nanometers. They're both distance. I don't know what to do. We have that magic word which is called Google. You can do a Google search and you can see what my smallest unit is from miles to nanometers. We do know that we have a unit called feet. I'm going to put my numbers in. Again, this is per hour, per 1 hour. I'm going to start going down as far as my units. I've got miles. I want to go to a real small one. So now I got miles here. And we don't really want to go miles because we know that's going to be the big one. And we're going to go down to feet. It's probably the easiest one. We know that's the big one. You know feet is a little smaller. If you look on the calculator, you will see 5,280 feet on the internet. So if you want to do a Google search, say, this is a bigger one than this one, say 1 mile equals how many feet, it'll pop up that number. So we got miles cancel out, now I'm in feet. I want to go to nanometers. So there's a way I'm going to be able to get to that, but I'm first of all going to have to go to a smaller unit. So how many feet? Well, feet. How many inches are in a foot? Next smallest unit. 12 inches, 1 foot. Since we're going to 12 nanometers, you could put yards. I don't know why, but you could put yards, but you're actually moving in the wrong direction. You want to keep getting smaller down to this one. So we've got feet, feet cancel out. Now I have inches. Inches goes to the bottom. And this is now my way of getting to something called centimeters. So we got centimeters here. Which one's the big one? Inch is the big one. Centimeters is going to be 2.54 centimeters. Now I cancel these two out. Now I can continue moving. So now I got cm at the top. I'm going to cancel out by cm at the bottom. And then now I have my smaller unit, which is nanometers. Which one's the big one? Well, we're taking a look at this and knowing how these are all set up. I know this one's my big one because nano's way down here. So my big one is centimeters. And now I'm going to go to nanometers. All I have to do is start counting. I am going to want to put an exponent here. 1, 2, 3, 4, 5, 6, 7. Again, if you want to put a bunch of zeros, that's fine. But am I in nanometers now? That is my objective. Now I got to go from hours to seconds. That will be my last step. Don't forget I'm not done because I've only found this. Now I want to find this one. So I got hours at the bottom, hours at the top. Next smallest unit from hours is going to be minute. Which one's the big one? Well, big one's hour. 1 hour equals, how many minutes are in an hour? 60 minutes. Hour, hour, those already canceled out. Now I'm at minutes. I got to go to seconds. Minutes bottom, minutes top. Next smallest unit is seconds. Which one's the big one? Minute. Smaller one, 60. Now I'm in seconds. Now I'm done. So this one's a little longer step one, but you notice either it's 150, follow the same pattern. So I got 2,500 times 5280 times 12 times 2.54 times a lot of numbers. 1 times 10 to the 7th. And then I'm going to divide it by those two numbers together, which is 3,600. So again, just remember, if you're not caught on already, this is multiplying all these numbers together, drawing a line, and then multiplying these two numbers. That would go at the bottom. And my other number, which is 4.032, 4.02336 times 10 to the